So welcome to HashiCorp Digital 2020, and I'm going to talk about shifting threat modeling to left with Terraform today. So a bit about me. My name is Moolchandani. I'm co-founder and CTO at Acryx. I'm a security enthusiast. I've been in security space for over 15 years now, and I've worked in various different security disciplines such as DevSecOps, red teaming, compliance, audit, and threat intelligence. And my favorite adversary technique for attack is waterhole attack. And I love mechanical keyboards, especially Xylem switches and SA keycaps. A little bit about Acryx. So we provide codified cloud-native security products that self-heal cloud infrastructures. And that's why you're seeing a jellyfish out there, which reflects self-healing. We're a Bay Area-based company, and we are the primary contributor to the open source tool TerraScan. And we also are a HashiCorp partner. So what are we going to talk about today? Well, we're going to talk about threat modeling, and we're going to also talk about how we can perform threat modeling for cloud infrastructures using Terraform. And also, we'll be able to discover today how the rich data that is contained in Terraform code can be used as input for threat models. And we're also going to see some demos on security analysis of Terraform code. And we're also going to talk about threat modeling processes and how we can map threats to kill chains and breach paths. And we're also going to take a look into a demo for that. So let's jump in. So we're going to quickly see what is the history of threat modeling. We're going to talk about what is a threat. We're going to look into what is a threat defense. And we're also going to talk about, at high level, how a threat model looks like. And oh, by the way, if you can notice the killer sea turtle, they are the top threats for the jellyfish. And so the jellyfish can self-heal if the turtles are attacking them. So what's the history of threat modeling? Well, although threat modeling techniques, have been used in the context of attack and defense since very long time, but in computing space, threat modeling has become popular only in recent times, right? So in 1977, the concept of architectural patterns, which was introduced by Christopher Alexander, that was a seminal work that introduced this concept of architectural patterns, based on which Robert Bernard in 1988 performed the first attacker profile-based analysis on an architecture pattern. And then in 1994, we had Edward Amoruso creating the concept of threat tree in his famous book called as Fundamental of Computer Security Technology. And then came our favorite threat modeling technique, STRIDE, from Lauren and Prerit in 1999. And then the time kept on passing by. And then in 2020, we had Russian gang approaching a Tesla employee and offering $1 million to plant a malware. Well, what has that got to do with the history of threat modeling? Well, that's what the threats are, And did they threat model for this scenario? We're going to see a lot of different ways how the threat models can be built and threats can be dealt with in this talk today. You'll be able to see how the threats can be analyzed and how the threat modeling can be performed just by looking into Terraform code. So what is a threat? Well, the classical thought says a threat is something that can cause harm, right? But the more modern thought uses analytical nuances to define and describe the threat as something which has the intent, has the capability, and also has the opportunity to cause harm, right? That is what is a threat. But as a threat modeling practitioner, over the period of time, I have taken liberty to add my own nuances to it. So in my opinion, a threat is a phenomena or situation that is adversarial in nature and realization of which can cause damage or impact to the target. But then there is something else called as threat agent, which is an entity that can possess skill, intent, motivation, and capability to project threats in order to cause harm or impact to the target. And the examples are malicious cloud admin or internet base attacker, so on and so forth, right? Now, what are threat defenses? Well, defensive techniques that are countermeasures that can protect you against threats are threat defenses. They can be built into designs, whether software or hardware. And the countermeasures can be implemented as security controls, such as preventive security controls, patching, hardening, access controls, encryption, etc. Detective security controls, such as enabling logs, monitoring, IDS, etc. And also corrective security controls, such as backup, recovery, and healing. Now, threat model, right? So how is threat modeling performed, right? So essentially, a threat model is nothing but a matrix of assets, threats, and controls, countermeasures, right? So in the context of cloud environment, what are the assets? These are your compute, network, storage resources, and other resources that you build or provision using technologies like Terraform, right? So threat modeling process requires you to build flow diagrams and also identify trust boundaries and build them, right? If I were to quickly talk about trust boundaries, a trust boundary, you can see on the right side, is basically a context which allows free flow of communication between the entities that are part of the trust boundary, right? So in this case, you can see a subnet, which is a trust boundary containing two assets, A and B. They can communicate with each other. That is a trust boundary. Now, trust boundaries can be formed based on network, identity, access, or privilege, right? But then the threat modeling process also requires you to identify security gaps and map them to attacker capabilities. What are the attacker capabilities? Well, they are reconnaissance, weaponization, delivery, exploitation, exfiltration, and others. These security gaps, when they are mapped to attacker techniques, and when they are analyzed by plotting the trust boundaries and also the flow diagrams together, that is when you are able to identify threats. And these threats can be then identified for cloud infrastructures as well, which we'll see in next few slides, how we can use Terraform to discover threats and perform threat modeling. Now, as a quick example, this is an example of an untrusted group, a subnet, which has a asset A, but the asset B is located outside of subnet. And then you have a subnet which, if has access to a, say, malicious admin, then that threat which is available for this subnet will be available for all the entities. That means a threat which is available to a trust boundary will be available to every asset which is located in that trust boundary, right? So what are the popular threat modeling strategies? Well, STRIDE, we all know about STRIDE. Spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. These are some of the strategies which we can identify and apply to our threat modeling processes. Then you have CAPAC, Common Attack Pattern Enumeration and Classification. It's a project from MITRE, which is a very good library of attack patterns and can be used to identify threat techniques. It can be used as an attack library as well. Now, CAPAC is good for analysis of attacks and threats, but then MITRE also has another project called as ATT&CK, which is basically a framework, very interesting framework, which also extends to cloud now. And it allows basically to map the tools, techniques, and procedures, which are otherwise also known as TTPs, from attack groups to attack phases. And lastly, the kill chain. So kill chain from Lockheed Martin, very popular technique again, which is used to determine if you have different types of attack phases available in your model, which also maps to the attacker capabilities. So we're going to discuss today how we can use kill chain and attack framework later in our presentation to identify threats and map them to these attacker capabilities and try and detect breach paths. So why do we want to threat model using infrastructure as code, right? Well, first is we can gather data required for performing threat modeling on cloud using Terraform code. And in next few slides, we will see how we can create asset inventory, relationships, configurations, identify network, identity, access, and privilege-based relationships, and also trust boundaries, just by analyzing the Terraform code. And that's not all. Terraform code is also very, very useful in detecting security issues. We will be using open source tools today to identify those security issues and apply to our threat models. So first things first, asset inventory and resource configurations, right? How do we identify that using threat model? In this sample, you are able to see that the Terraform code actually contains the resource definitions and the configurations. If we were to build a database of all these resources and also these configurations, we can build a very good representation of all the assets that are being managed and built using Terraform code. Second, resource relationships, right? There are various types of relationships that we need to identify to build context around the threat modeling process. In this example, there are two different Terraform files that I'm referring to, both for building AWS environment. One holds the information about a VPC, and the other one holds a relationship that the VPC has with the defined security groups. The second Terraform file on the right holds the information about the security group. This relationship later will allow us to build a network relationship diagram between the assets and also their peer networked assets, because we understand how the security groups actually allow the communications to flow between one asset and the other. This is a specific example that we are talking about with respect to Terraform for AWS. Next, network relationships. How do we build network relationships? So in this example, you can see the file on the left side contains a compute instance with a relationship to a subnet. And then the subnet is present in the other file. This allows us to identify if a given asset is based out of a particular subnet or not. If we record this subnet, we treat the subnet as a trust boundary, we know that this asset is part of this trust boundary now. We take a record of it, and then we work more on that for the analysis purposes, right? Next is how to identify identity, access, and privilege relationships that are shared between various different assets, right? So take example here. In this example, we have a Terraform code, again, from AWS point of view, and we have a EC2 instance with an instance profile defined. The instance profile actually now has a role, and the role has a policy. This policy basically allows a S3 bucket access, right? So what do we determine out of this? What we determine is that in this case, we have an EC2 instance which has an identity and access relationship to another S3 buckets, right? This is the important information, very important information. So as I was previously explaining, why it is important to identify these relationships. Because the attackers are also spending a lot of time in your network to identify and detect exactly these relationships. Once they identify these relationships, they take advantage of these relationships, and then they take advantage of the security gaps which are available on these resources which are sharing these relationships, and that's how the attackers also move forward in their attack phases. So as defenders, all what we do is discover these relationships before the attackers do, and uncover the security weaknesses that could have made any attacker successful. That is what is threat modeling process. That's where threat modeling helps. So how do we identify trust boundaries now using Terraform code? So in this example, we're going to talk about two Terraform files. One is instance.tf, the other one is route.tf. We note that the instance definition has a reference to a subnet ID. The subnet ID is associated to a route table, and then the route table association has a route. And this route could have an internet gateway attached to it, or any other route which could be exposed to internet. This way, we identify whether this EC2 instance is actually exposed to internet or not. And if it is exposed, it is part of which trust boundary? We exactly know what is a subnet, which is containing this EC2 instance. This relationship and this information is used to build the trust boundaries. And this is very important when we are identifying security weaknesses on this EC2 instance or the other resources, how these weaknesses can help attackers take advantage of these relationships, right? Now, all the examples that I was showing in the previous slides can be tried and tested and also can be played around with using our open source offering called as KaiMonkey. So KaiMonkey is a purposely built vulnerable library of Terraform code Basically, this project allows you to provision a two-tier architecture on any cloud environment, and then it allows you to play around with the vulnerable code. You can do this testing, and you can play around and identify the relationships that I was previously describing. So how do we identify now security problems on all these different assets or resources that we've been discussing about? So primarily, we need to identify misconfigurations, vulnerabilities, and exposures on all of these assets that we've been discussing. Once we have identified the relationships and created trust boundaries, and we have the asset inventory, we need to identify security misconfigurations that we can superimpose on top of them to basically move forward in our threat modeling process. So security scanning, how do we perform that on Terraform code? Well, we have an open source offering, TerraScan, which can help you in this. So TerraScan comes with 500 plus security checks. It supports both Terraform as well as Kubernetes YAML files that you can use for performing the scanning. So in this quick demo, we're going to see that how TerraScan works. So you can see we have a library of Terraform code. We just did the ls on it. All the Terraform code is going to undergo now the scanning using TerraScan. So a simple command, TerraScan scan -t AWS performs the scanning, and it results in the violations. So all the violations are reported for the TerraScan and the scanning process that has continued. Now these violations can be utilized for performing further analysis. If these violations that are reported against each asset, so if you notice, we found some ports are open, VPC flow logs are not enabled, and many others. All these violations can be used now for performing further security analysis using the relationships that we have built previously, right? And for all our audiences who love to use Terraform Cloud for provisioning their Terraform code and their cloud environments, we have integration available with Terraform Cloud as well, using a free tool at app.acryx.com. I'm going to show you a quick demo how the integration works. Basically, you'll be able to integrate with your Terraform Cloud and perform the security scanning much in the same way how you saw TerraScan can perform security scanning of infrastructure as code. All what you have to do is go to your TFC, copy your tokens, paste them into our free tool at app.acryx.com, and integrate with your running plan on your TFC, and then let the plan run. Once the plan runs, automatically it will scan for all the security violations and security checks as well. And if the checks are failing, it's going to fail the plan and report the violations. So we're just adding a quick Sentinel policy there, which is going to basically connect with our free tool. And the free tool now is ready and integrated. We have run the plan is running, and we are seeing now the results are going to be available. The policy check is queued. If the policy check fails, that means the security checks fail, and you are able to see the security results. So that's our integration with TFC as well. Now, how do you identify vulnerabilities for your assets that you have identified from Terraform code? Well, one way to do that is identify, in case of AWS, identify your AMIs, and then figure out if your AMIs have got vulnerabilities using several different scanners which are out there, and then use that information for determining more attack vectors and attacker capabilities. That's how you can utilize vulnerability information as well, if you can gather that information by looking into Terraform and the EC2 instances as well as the AMI IDs. Exposures, very important. So it's so important to determine exposures because that is going to help us map the kill chain phases like reconnaissance and delivery. If the exposure is detected, it will also allow us to determine the impacts of the threats that are detected, right? So how do we identify exposures in your systems, in your architectures? You can use TerraScan for performing the scans that we just previously showed, and you'll be able to identify ports which are exposed. You'll be able to identify wide open security groups. You'll be able to identify S3 buckets which have public access, and you'll also be able to identify other services which have overly permissive IAM policies, such as, which has principal as star, right? Very important. Once you've identified these exposures are going to be extremely useful for plotting them against the trust boundaries as well as the security violations that we have been talking about. Thank you very much for the time today. And if you have any questions, feel free to send them over to me. You can contact me on LinkedIn, Twitter, my email, and also feel free to use our free tools and open source tools, TerraScan, KaiMonkey, and also make sure that you're using our free tool at app.acryx.com for performing the full threat model. Thank you.